Okay, for this discussion, so this is all about network topology and network data transmission. So basically, the term topology means it is a way of laying out the network. It's either physical or logical. So when we talk about physical topology, this is how you connect cables or how the wires are run or the cables are run on the network or how you physically connect your devices. So ito yung paano mo kinokonekta yung mga devices. That is the entire physical topology. Again, the physical topology is how you wire the computers and devices over the network or the different network devices on a single network. So that is what we call as physical topology. When we talk about logical topologies, so it describes how the network message travel. So basically, the logical topology means it's the configuration of your network, so that data travels over the network the way you want it to be configured. So this means that this is the configuration of the network. Okay, so one example of a logical configuration is IP addressing. Okay, so when you talk about physical topology, so you have to consider the physical structure of the transmission media. So meaning to say, gaano ba kaganda or kaano ka stable? So how stable is your network in terms of its physical structure? So you have to make sure, you have to think of the design of the network in terms of the physical topology to meet the requirements of the business or the organization. So there are different characteristics and considerations when you are choosing a physical topology or you are designing the physical topology. So, syempre, our main goal when you are designing a network infrastructure is to have a healthy network or a network which works 100%. So that's our goal. So for us to achieve that, you have to consider some of the characteristics and considerations for you to be able to have that quality of a network. So ano ba yung mga, in terms of physical topology, these are the characteristics that you have to consider. So the first one is relative ease of installation. So gaano ba siya kabilis i-install? So how easy to install? Next is relative ease of reconfiguration. So if you wanted to move computers, so gaano mo ba siya kailangan i-reconfigure or rewire or reconfigure? So that's the second characteristic. So the ease of reconfiguration. The third one is ease of troubleshooting. Do the physical topology or connectivity or the setup mas madali siya i-troubleshoot? Is it easy to troubleshoot over a different physical connectivity or topology? So you have to think of in the long run, is it easier for you to troubleshoot networks? Okay, so that's another characteristic. So next one is maximum number of units affected by a media failure. Okay, you have also to consider the design structure of your network in terms of physical. So kasi di ba, you have to make sure that it is easy to troubleshoot. At the same time also, when you are troubleshooting networks, so as much as possible, you minimize the number of units that may be affected by a media failure. So the consideration is, what do you think is the maximum number of units affected by a media failure if in case there is hardware that will be defective or masisira? So gaano kalaki ba yung scope ng damage on the network? Ano ba yung portion of the network na hindi na magfa-function? So those are the different considerations na dapat nyo tandaan. You have to consider the four characteristics. The first one is relative ease of installation, relative ease on reconfiguration. The third one is relative ease of troubleshooting, and the fourth one is the maximum number of units affected by a media failure. Okay, so we have the different physical topology. So we have the bus topology. So typically uses long cable backbone. Short cables called drop cables, or the BNC cable or the Bionic concealment cable. So named after the inventor of that cable. Okay, so in terms of ease of installation, okay, by the way, this is the this is the bus topology. So as you can see, computers are connected in series. So with the coax cable, so this is a coax cable. So this is coax cable or coaxial cable. So I think you can see that type of cable used on TV antennas. So the one that you connect to your TV are coax cables. And same also as well with yung mga analog CCTV. So it uses coax cable. So basically the bus topology before, so that is earlier versions of networks. So it uses a coax cable. So basically on both ends of the coax cable, since that is only a single line coaxial cable, and you have your drop cables here. These are your drop cables. Okay? So the drop cables and the backbone or the coaxial backbone, ginagamitan siya ng T-connector. Okay? So it uses T-connector to connect the computers on the network. So there's a terminator on both ends. So the purpose of that one is that para if, for example, if this computer send data over this computer, kapag nakarating yung data dito, automatically, the transmission will be terminated para hindi na siya pumabalik-balik on the cable. So that is the purpose of the terminator on both ends of the coax cable or the bus topology. Okay? So with this type of physical connections or physical topology, so we have to consider, first is ease of installation. So relatively easy to install. Simply string the backbone cable from side to side. Kasi all you have to do is just have a drop cable again, a drop cable and T-connector, then connect another computer. So that's easy of in terms of ease of installation, so madali lang siya install. So second is ease of reconfiguration. Because most bus topologies are laid out to minimize the required amount of cable, reconfigurations tends to be moderately difficult. So kasi if you're going to move this one here and move it somewhere, let's say on medyo malayo yung distance, so you have to do to change the cable and or add cable papunta dito. Okay? So basically it's a little bit it's moderately difficult for you to expand or to reconfigure network. So ease of troubleshooting. When troubleshooting media, you isolate the fault to a specific segment because it is based on a single cable. Fault isolation is relatively difficult. So yung fault isolation kasi, since this is only on a single cable, ang hirap i-detect kung aling portion ng cable ng network yung aling drop cable, mahirap identify because you only have a single cable which runs on the network. So there's no device na pwede mong i-isolate one by one yung mga drop cables. So all you have to do is just remove the T-connector, then connect again before you can isolate computers or failures or problems. So nangyayari kasi you have to isolate it first. Then if you're going to remove the T-connector, so you have to reconnect it again. Then, before you can isolate computers if yun yung nagiging cause of problem to the network. So, in terms of ease of troubleshooting, so it's relatively difficult. So, units affected by media failure, bus cable faults or break stops all communication. So, every device receives excessive noise due to signal reflection. So, in terms of units affected by media failure, especially kung masisira yung backbone, since all of the computers rely on a single bus or single bus connector or cable, so everything relies on a single cable. So most probably that all computers on the network will be affected if the backbone is magkaka-problema. Okay? So that is the units affected by media failure. So, gaano kadami ba? So, relatively, mas madaming affected units or computers on the network ang maapektuhan when you are using a bus topology. Okay? So, we have the ring topology. So, it's a circular topology or closed loop of point to point. Each node is connected to the two nearest nodes, so the entire network forms a circle. So, this is a ring topology. So, basically, computers are connected from one computer to another. Then, the other computer is connected to another. So, basically, they are passing tokens. So, this is what we call as token passing. Or, the data is being transmitted on a circular pattern. So, basically, one computer will pass to another computer. If that is not the destination, it will send to another computer until it reaches, let's say, for example, this is the destination. Okay, so that is the ring topology. So, in terms of ease of installation, at initial installation, it is moderately simple to install. Kung makikita nyo man, just connect one computer to another, then another computer to another computer. So that is how you connect ring topology. Ease of reconfiguration, ring networks become harder to reconfigure as the scale of relocation increases. Ring segments must be divided or replaced with two new segments each time a segment is changed. Kasi diba this is a ring topology. So if you're going to connect computers here, so you have to cut on connectivity here. Okay? So after cutting this connectivity, you're going to add this segment and another segment here. So that's how you expand the ring topology. If you're going to add computers over the ring topology network. So it's relatively harder to reconfigure. So in terms of ease of troubleshooting, because each device incorporates a repeater, you can easily find faults. Okay? So, mas madali. So, you probably have to just disconnect. For example, in this ring network, halimbawa, the problem is on this computer. Okay? If you're going to disconnect this one, if the network still works, so it means if the network still have the problem, so basically, hindi ito yung naging cause of problem. So, disconnect this one again, disconnect this one again, and until you detect what causes the problem to the network. So, in terms of ease of troubleshooting, so you can easily find faults in a ring topology. Units affected by media failure, most ring uses only one loop. Faults in a single loop system affects most devices on the network. Since naka-ring connection yung mga computers, so the number of units that may be affected depends on the location of the fault. Halimbawa kung dito, most probably, lahat to magiging affected on the network transmission. So basically, the maximum number of units affected by a media failure or a hardware failure on the network will be based on the location of the fault. Okay, so that is the properties of or characteristic of a ring topology. So we have the star topology. So this is the most used star topology nowadays. So you use a network on you use a central hub or switch on the network and connect computers here. Okay. So in terms of installation, it is moderately difficult to install, especially if the segments or the computer or devices that will be added is a little bit has medyo malayo or medyo malayo on the switch. So most probably if you're going to connect another computer, so baka masyadong mahaba yung cable. So it depends on how far the location of the computer or device that will be added. Okay? So, in terms of ease of installation, it's moderately difficult to install. The design of the network is simple, but you must install a separate media segment for every arm of the star. So, just like adding multiple segments para if if para hindi masyadong malayo yung mga kable, you can always add segments of the network. Okay? In terms of ease of reconfiguration, so are relatively easy to reconfigure. Moves, adds, and changes do not involve more than the connection between changed network devices. So when you reconfigure, so if you're going to place this computer somewhere else, so hugutin mo lang naman siya dito at ilalagay mo lang siya on other port of the network or maybe on other segment of the network, then may babalik mo yung device na to. Okay? So in terms of reconfiguration, mas madali siya. Okay? So in terms of troubleshooting, so it is also easy to troubleshoot. So again, with the discussion with the network structure, so di ba we have from the backbone to the segment, to the nodes, to the entire topology, to the topology. So basically, isolation of devices are easier. So you isolate the segment. If the segment, kung yung segment na yan causes problem, so maybe the node on that segment causes also problem to the network. So on a start topology network, it is easier for you to connect, to isolate problems. Okay? So ang gagawin nyo lang is isolate, whether it's a backbone or a segment or a node, just isolate the cable, then detect if that is the portion which affects the network. Okay? If that is the one causing the problem, whether it's the backbone or the segment or the node, so mas madaling isolation on star topology. Okay, units affected by media failure, it handles media faults relatively well. If a media fault occurs on the network, you can use hub or switches to identify and remove offending links from the network. So same as well with the isolation. So if the location, the maximum number of units affected by media failure depends also on the location of the hardware. So if kung yung failure is mostly on the top level segments of the network, most probably mas madaming maapektuhan on the network. Okay, let's say for example, if this is your structure, you have your switch, then you have another switch, then you have another switch here, and you have another switch here. Okay, so for units affected by media failure, it depends on the location of the problem. So let's say if the problem is on the topmost level of a segment, most probably mas madami yung maapektuhan pababa nung segment na yon. Okay, so next is we have the mesh topology. So the mesh topology has a point-to-point connection between every device in the network together with another topology. So to simplify, this is a mixed topology. So it's a combination of two topologies on a network. Because each device requires interface for every device, it is considered practical. Okay, so this is the mesh topology. So as you can see, this is combination of ring and star topology. So there's a link. There's a link on which is on a ring topology, and also we have on the star topology. Okay, so in terms of ease of installation, it's difficult to install because you are doing two topologies at the same time. So basically, you're doing two networks at the same time. So in terms of reconfiguration, difficult to reconfigure. Same with the reason above, that since you have two networks, or you are actually like doing two networks at the same time, mas mahirap pa rin yung reconfiguration. If you're going to move computers, you have to connect it to two networks, which is part of the entire mesh topology. In terms of troubleshooting, so easy to troubleshoot because each medium link is independent of all others. So ang kagandahan lang kasi nito, you have two topologies on a single network. So it means that you have the availability of other network if a particular link fails. kung isang network may is mag-fail, meron pa rin sasalo on your network. So that's why, while troubleshooting networks, meron nagra-run pa rin yung network mo because of one topology na ginagamit. Okay, the other topology na ginagamit. So next is units affected by media failure. Resist media failures better than other topology. Same with the reason of number 3 or ease of troubleshooting. So since you have the backup network, so since again we have two networks on a one physical topology, so you have a backup. So basically, if there's a media failure, you have enough time to troubleshoot. Siguro bibihira na may mangyari na both of the topologies or the network is masisira. Okay, so the unit affected is minimal in terms of mesh topology because there's always high availability of the other networks if there will be a problem, if there will be the problem on the other network. Okay, so this is the mesh topology. We have the cellular wireless. So ito yung mga Wi-Fi connectivities. Okay, so in terms of ease of installation, so mas madali siya because all you have to do is just place the access point, which is as much as possible centrally accessible to the devices on the organization or the location. Ease of reconfiguration because it does not require cable, it does not require configuration as users move. So all you have to do is just move the computers or device. So as long as their signals are still accessible, so basically no need for reconfiguration. Ease of troubleshooting, relatively simple because each hub interacts independently with each devices. So basically the devices interacts with one another separately. So since yun nga, same with the reason of reconfiguration, so mas madaling troubleshooting. No need to disconnect it from network. So just isolate a particular access point or segment of with access points on the network or the device itself. Okay, mas madaling tanggalin yung device on the network. Units affected by media failure, when portion of it fail, all the units in the cell assignment range are affected. So most probably kasi the devices relies on a central access point. Or the central access point, or your router, or a hub, or access point. So basically, kapag ito yung nasira, most probably, most of the devices are mawawala on the network. Okay? So it depends on the location of the device na sira. So kung gano'ng kadami yung maapektuhan na network, devices. Okay, so we have also the different types of network backbone. So we have the serial backbone, distributed backbone, collapsed backbone, and parallel backbone. Okay, yung serial backbone, so also called daisy chaining devices or hubs or switches. So it's a linked series of devices. So hubs and switches are often connected in daisy chain to extend a network. Hub gateways, routers, switches, and bridges can form part of a backbone. So it can be hub, switches, or routers. So this is what we call as this is how the serial backbone works. So, ang ginagawa lang is, you do series of devices, okay, to form the network. That is possible. Pwede ka lang extend, just add another switch, then computer here, another switch, then computer here. Okay, yan yung tinatawag na serial backbone. Okay, that can be done on the network. Kaya lang, always remember that in this kind of backbone, so always remember, diba, going back again to the network structure, so lagi yung tatandaan that the design matters, the physical design matters in terms of fault tolerance, kung gaano kalaki ba yung maapektuhan on the network. Let's say, nasira tong switch mo, switch 1, nasira to. So most probably, lahat madi-disconnect on the network. Especially, halimbawa, nandito yung server. Okay, nandito yung server and you have applications. All computers here do have applications that connect to this server. So, kung masira to, lahat ng operations nyo or computers connected to the network is sira. And the longer it is, the most difficult it is to isolate. Kasi, tatanggalin mo to. Tatanggalin mo muna yung dulo. So, sira pa rin yung network. So, most probably, this is not the one causing the problem. Tanggalin mo tong switch na to. Sira na naman, then so on and so forth. So, isolation of the problem is a little bit difficult on a serial backbone. And also, the number or the maximum number of units affected by a media failure here is masyadong madami. Especially if yung masisira is on the topmost level of the network. Okay, so we have to consider a serial backbone can be done kasi minsan hindi because of the nature of the requirements. Let's say for example, mahirap na siyang gawing star topology and mahirap na yung extension network. Wala ka ng way but just to add a switch. So, pwede yun. That's possible. So, you can use the serial backbone. Okay, we have the collapsed backbone. Okay, you have the switch and you have segments, just like what I've discussed on the network structure. You have segments and you have your nodes. Okay, so this is the collapsed backbone. Okay, so the collapsed backbone is in terms of fault tolerance kasi. So basically, kung masisira yung isang segment, hindi niya maapektuhan or it does not affect the entire network. Okay? So, aside from fault tolerance, also the importance is fault isolation. Mas madali. Kasi all you have to do is isolate this one. Then, if the network works properly, then ito yung cause of the problem. Halimbawa, hindi ito yung cause of the problem. Connect it again. Try to disconnect this one. Then, tingnan nyo. Okay, bigla nagka-problema. So, most probably, this is the problem on the network. So, fault isolation is easier on a collapsed backbone. Okay? So, this is also a star topology. And the way the backbone is being connected is through a collapsed backbone. So, at the same time also, yun nga, minimal yung affected areas or computers or units on the network if only the segment is being kung nandun lang yung pinaka may problema. Okay? So, you just isolate the segments and palitan kung ano yung dapat palitan here. Then, balik nyo sa network. Okay? So, that's the collapsed backbone. So, we have also the distributed backbone. It is like a collapsed backbone except that segments are divided by routers. Okay? So, kasi sa gantong setup, each segments, this is a segment, this is also a segment, this is also a segment. In this network, network 1, let's make it, this is segment 1, segment 1, segment 2, and segment 3. So, they are physically connected with one another. So, because of the physical topology, they are connected with one another. But since this is a distributed backbone, and distributed backbone are connection of segments using a router. So, pag gumamit na kayo ng router, the segment is a separate network. So, this is network 1, this is network 2, and network 3. But still, they can communicate with one another. So, ang concept lang kasi nito is that if there will be a problem anywhere on this segment, wala siyang hindi affected yung other segment on the network. So, meaning to say, you are physically connected to the network, kaya lang, in terms of failure, so pwede siya maging separate. Okay? Mako-confine mo yung problem on the segment. Okay? You confine the problem on the segment. So, hindi niya maapektuhan yung other segments on the network because those are divided with routers. So, once the network is divided by router, it means that you have separate networks. You just do routing para magkaroon ng communication with one another. Okay, so that's the distributed backbone. So, we have the parallel backbone. Actually, the parallel backbone, just to simplify, you have two backbones. So, para pag nag-fail yung isa, gagana pa rin yung isa. Okay? So, there's a redundancy of backbone on this network kapag gumawa ka ng parallel backbone. But, remember, we have the loopback cable problem. So, I'll be discussing that on network troubleshooting. So, yung naka-loopback cable, yung pag binalik mo yung cable dito, that may cause problem to the network. So, basically, possible yan with proper configuration of switches. So, you can have the parallel backbone. Okay, so we have also network data transmission. So just to simplify, so we have the three network data transmission. We have the unicast, broadcast, and multicast. From the word itself, the unicast is a transmission between one computer to one computer. A broadcast is a transmission from one computer to all computers. And multicast transmission is a transmission from one computer to many computers, but not all computers. Again, the unicast is one computer to one computer. The broadcast is one computer to all computers on the network. The multicast is one is to many but not all on the network. Okay? So this is a diagram of the unicast. So this is one computer to one computer sending to one computer. The broadcast is one computer sending data over all computers on the network, while the multicast is sending data to many computers. It may be 3, but not all computers. Okay, so that is the unicast, broadcast, and multicast. So an example of this one, this computer send data to this server or ask service to this server, and this server will reply to this client. Okay, so this is a unicast transmission. So for broadcast, router A sends data to host A, to host B, to host C, and to host D, and to the server. So data is being received by all of the devices and computers over the network. So that is the broadcast transmission. And we have the simple multicast transmission. So router A sends data to host A, to server, and to host D. Okay, but not on host B and host C. So meaning to say, this is a multicast transmission. So meaning to say, it is data being sent by one computer to many computers on the network, but not all computers on the network. Kasi if that is all computers on the network, that is a broadcast transmission. Okay? So just to review, we have the classful IP addressing, since I had lesson naman last time with classful IP addressing. So you have 32 bits of data or bits of bits on an IP version 4 address. So that's from 0 to 255. Okay, for class A, that's 1 to for class A, if the first octet falls under 1 to 126, that's class A. If the first octet, again, if the first octet falls under 1 to 126, that's a class A network with a subnet mask 255.0.0.0. For a class B, that's 128 to 191 with a subnet mask 255.255.0.0. For class C, that's 192 to 223. So the subnet mask is 255.255.255.0. For class D, that's 224 to 239. So that's reserved for multicasting. And for class E, that's 240 to 254. That's experimental. Okay? So again, just to review again, for class A, we have the W, X, Y, and Z. So the first octet, this is the first octet, second and third and fourth octet. So for class A, since the subnet mask is 255.0.0.0, the network ID is the first octet, and the second, third, and fourth octet is the host ID portion. And for class B, again, the network ID is the first and second octet, and the host ID portion is the third and fourth octet. For class C, the network ID is X, Y, and Z, and the host ID is the fourth octet. the W, X, and Y, and the host ID is the Z, or the 4th octet. So for class D, that's the multicast address, and the class E is the reserved address, or for experimentation. Okay? So that will be all for my discussion for today. So in reference to this one, so after you watch the video, so kindly answer the assessment task on your Canvas.